First of all, thanks for the invitation to give a short talk. And as you said, I'm a bit underprepared. So what I'm going to do is just tell a little bit about one project that we are currently involved in, which has very little to do with medicine at the current point in time. But as it is one of the long-term perspectives we are working with, it might be interesting to this group. So my name is Balder Onarheim. I live and work in Denmark, but I'm Norwegian. I'm the founder of a company called Plato, which make neurostimulation devices. So not neurostimulation, but stimulation. I'm also the founder of the Copenhagen Institute of Neurocreativity, which is more research-based, and then I'm an associate professor at DTU. And since I don't know this group, I might be setting up people's toes by explaining things you know all too well, but I'm going to start at the beginning. So basically, we are working with two different types of neuro studies. We are working with what you see on the left-hand side, which is classical neuroimaging studies, mainly fMRI, but more recently also EEG studies. And then we're working with building devices that are designed specifically to interact with the brain. So, of course, as you all know, you have a whole range of existing devices that you operate into the brain and on different levels, but there are also more recent attempts with different types of non-invasive stimulation, and that's what we're working with. So the background for the Plato project actually comes from consumer devices, and you've probably seen various types of brain interaction devices. Here are three examples. The one to the left, they're all toys, but I think it's an interesting development. So the one to the left is a pair of ears that will sort of rise and fall depending on the frontal activity. And so on, I think these products have opened up people's understanding of the fact that the brain is actually something you can communicate with directly, but this is just one direction. Then more recently, a number of consumer devices using different types of neurostimulation has surfaced. So what you see here is Halo, which is a TDCS device for professional athletes. And then there's one in the middle, which is Think. They're now changed the position, so it's placed in the neck. Also using different electrical stimulation types. And then Plato, which is our product. And the motivation for us was actually, we've been following the development within specifically TDCS, but also TACS stimulation for a lot of years. It's probably, 7, 8 years now. And there have been quite some studies performed, but as everyone who are involved in this space know, it's a mess. There are too many variables, too few studies, too small studies, too few reproduced studies, and too low significance. There are a lot of problems with the current studies of TDCS and TACS. So transcranial direct current or transcranial alternating current stimulation. And what we wanted to do was basically try to collect data from people who are already using these technologies at home. And there's a huge community globally with people who are basically building their own devices and buying devices, cheap devices online, and sit at home and stimulate their brains. And I won't go into the ethics and the risk aspects, especially in the DIY community, but we know that there are, right now, there are more than 8,000 people who are doing this on Reddit. So the number of people is at least more than 8,000 people globally who are already using neurostimulation, some of them for treating diseases, some of them for treating depressions, other psychological, but also a lot of general performance enhancing devices. And what we wanted to do was to get access to the data from all these people, because if we could have an incoming data stream from 8,000 people who are using various types of TDCS, TACS, then we might actually be able to do more or better and stronger analysis on the data compared to what the current studies that are normally, 20 to 60 people. The bigger ones are hundreds, but it's still not on a massive scale. unfortunately, what we found out was there are no current devices that would allow for this. So the current devices that are on the market wouldn't offer us any data output from them, and most of the devices we're talking about are so, how to call it, dodgy, so that the data you would get, even if you could get it, wouldn't necessarily be sound. So what we have done is to start from scratch by basically designing a TDCS, TACS device for personal use for healthy consumers. And the idea is that the data that we collect from these users will hopefully over time give us a database of the different outputs from different types of stimulation, where we can do A/B testing and so on with our users. So just to give a very simple explanation, so in non-invasive neurostimulation electrical, you basically place 2 or more electrodes on the skull. Here you see a picture of me with a very, very early prototype, a physical breadboard version, and you basically make an electrical circuit that runs through the brain, or partly through the brain, in between 2 electrodes at a time. You can also do high-resolution TDCS where you split the current, but I won't go too much into detail with that. And in the current stimulation protocols that are used, both in a medical and in the non-medical space, are all based on averaging. So what you do is you take this sort of a wide range of studies that find similar effects or the same effect, and then you basically make an hypothesis of how that type of simulation will influence the brain, trying to sort of do a reverse engineering, so to say, of the findings from brain scannings. The problem with this is, of course, it's assuming that everyone has an average brain, which, of course, we don't. So the interesting thing that we are trying to investigate is if we give consumers access to stimulate their brains in different ways and collect the data, will we be able to do the type of analysis that could actually tell us more about the individual differences in the stimulation protocols. So this is an old product rendering. As you can see, it's a headset with 3 electrodes, with flexible electrode placements. In the current version, we have electrode placement on EEG 1020 scheme F3, F4, and P sets. And it's all run by a smartphone app that collects the data in 2 different ways. So it collects passive user data in terms of how often and which type of stimuli and so on that the people use, but it also allows for cognitive tests during or before, during, after stimulation, so you can track the single stimulation and also tracking a cognitive effect over time. The next generation products that we are working on are an integrated version of TDCS, TACS, and EEG. This is still super experimental, but in an ideal world, this is just a consumer device, but with proper devices and a big enough population who are using these for their own goods, if we could also read the actual cognitive changes while stimulating before, during, after, that could give us a better understanding of the actual current flow in the brains and individual brains, and how that could potentially give us more information about the healthy subjects that could, in a very long run, lead to medical applications. So that was basically it from my side. If you're interested in reading more about the project, here are some links. Also a TED Talk, TEDx talk by me, which is more research focused, and suggesting for more reading in terms of the more training aspects that we're also working on. So that's just some tips. So thank you so much for listening. I'm trying to navigate myself out of this.
I can navigate you out. Thank you so much. Dr. I have one question, and I forgot again. I'm sneezing so much. You said that you were not haven't applied it yet in clinical use. Are you in touch with the neurologists?
Yeah, of course.
And
so
how do they see this?
Yeah. So basically, we have on the team, we have a neurobiologist, a neuropsychologist, and a neurologist. So they're sort of taking the ethical approval process and so on. So basically, currently we are using it internally, and we're using it on people who are already applying TDCS. So it's more collecting data from people who are already using it, but that's more in terms of the passive usage data. So how they use it more than the results of it.
Okay. Then you said that there are some ethical issues that you didn't want to go into detail with. I was just curious, can you briefly mention some of them?
Oh, wow. Well, where to start? So some of the most famous applications of TDCS comes from the Army. You mentioned it to begin with. The Americans, or DARPA, has used it for sniper training to increase accuracy when killing people. And it's not official information, but supposedly it's also used for more experimental purposes in various Army settings, for instance, for drone pilots to numb the uptake of experiences while bombing people, basically. There was a study coming out some weeks ago where they also used TDCS to force people to tell the truth. So that's also another very interesting ethical challenge if you can use this technology to limit people's ability to make up stories and so on. I think that's one side of it. The other is, of course, the ethical challenges in terms of the DIY side of it, because there are a lot of DIY products that you can buy and order online, and the safety aspect of most of those products are at best critical. So I've seen some pictures of people with skin burns, and seen some pictures of people who are stimulating their brain with a DIY device that is on the same time plugged or connected to a charger, which sort of would technically allow for getting a full discharge of a power socket going to your skull. So that's more to the DIY challenges in neurostimulation.
But I get the feeling that there's a lot of issues that could fill a whole session itself.
Yeah.
Are there any other questions from the panel before I take all the time here?